Hello everyone. In today's episode I'm going to show you a simulation of the Intellec 8 system. I recently created videos about simulating the Intel 8008 CPU. So the Intellec 8 system was a development system based on this Intel 8008 CPU. So it makes sense to see the simulation of this system, and hopefully you have already watched the two videos about the simulation of the Intel 8008 CPU. So as you can see, when you start the simulation, you get the front panel. You also get Teletype. It's just a very basic system configuration, and as you may notice, when you start the simulation, it actually starts in halt state, and this is because this is how the Intel 8008 CPU actually started. So this is very different from today's computers, and also very different from other CPUs. When you start the system, it's actually in a halt state, and you need to send an interrupt signal in order to wake up the CPU from the halt state. Now if we look at the user's manual, we see here on page 107 of this manual that pressing the reset button causes the processor to begin execution of program at memory location 0 by resetting program counter to 0. All other registers remain unchanged. Now, in this manual is not clear exactly what the reset button does, but since you need to provide an interrupt signal, and you also need to provide interrupt data to the CPU, I'm guessing that pressing the reset button will actually trigger an interrupt and provide a jump to memory location 0. So this is exactly what I did in the simulation. When you press the reset button, the front panel will trigger an interrupt and will provide the code for a jump to memory location 0. Now, obviously, you need to have some code at memory location 0, since the monitor is not located there. For the purpose of this simulation, I provided an Intellec 8 monitor ROM, but the ROM is located at the end of the memory space. So it's obviously not located at memory location 0. So what can you do? You would normally use the front panel buttons here to enter an instruction at memory location 0 that would actually jump to a location in the ROM. However, for the purpose of this simulation, I already entered this instruction. It's actually preloaded. If we look at this system with Teletype Simulation in the simulation JSON, you can see here we have front panel, the Teletype, the CPU, the ROM, which is loaded with monitor version 3.0, and we also have the RAM, which loads a hex containing a jump to 3800, this is in hexadecimal, which corresponds to the monitor starting address. So it's preloaded. Also, if we look at this listing or the assembly file for this jump 3800, we see that what it actually does is just jump 3800. This is encoded in hexadecimal like this, 440038, so 3 bytes. And we can use the Intellec front panel to check these values. So we have this first byte of memory location 0. We see here the address and here the data, so this is 4. Now on the next location, so this is memory location 1, we have a 0. And in the next location we have this value which should correspond to 38 in hexadecimal. And indeed here is a 3 and here is an 8. So as I said, everything is already set up. We can just press the reset button, which I'm going to press now. And the monitor has started. We see here the monitor prompt, which says 8008 v3.0. I'm trying to enlarge this window. Okay. And now we can run monitor commands. For example, we have D010. This will display the first 10 locations in memory. We see there are additional values here. These are being used by the monitor to store data, but the first memory locations remain unchanged, and this is our instruction. We may also use W to dump this in hexadecimal format, in hex format. And of course we can use any of the monitor commands associated with this version of the monitor. The front panel simulation, I'm going to make a video specific to the front panel simulation. It includes much of the operation of the real front panel, except for the pass functionality. This is not yet implemented. So thank you for watching, and I hope you will enjoy playing with this simulation. Remember to leave comments and subscribe to the channel if you enjoy the videos. Thank you, and see you next time. Bye.